Okay, what's up guys? Today is February the 24th and we're going to do another LeetCode daily challenge, so let's jump right into it. Number of subarrays with odd sum. So given an array of integers, return the number of subarrays with an odd sum. Since the answer can be very large, return it modulo 7. So I'm just going to say return result mod 10 to the 9th plus 7, just so I don't forget, and then I'll just have result is 0. All subarrays are 1, then 1, 3, then 1, 3, 5. Let me think a little bit more. Right, because there's two ways that I could go with this. Yeah, if the array is, okay. If the length of the array is 10 to the 5th, originally I was thinking about doing some like brute force, where we like construct all possible subarrays, but that would be, that wouldn't be efficient, right? Probably get like a timeout or something. So now that we cannot use brute force, we'll probably need some sort of dynamic programming. But yeah. Yeah, I don't know off the top of my head. I feel like it's something with dynamic programming, but other than that, I don't know. So if we have 1, 3, 5, okay, let's just loop like index by index, I guess. So let's start with 1. 1 is odd, so maybe we'll just store 1 somewhere. So now we move on to the 3. Three itself is odd, so we're definitely going to use it again. But then we also have to consider 3 plus 1. Okay, so we consider everything that is in this. I don't know, maybe it's a set or something. I'm not sure. Or maybe it's like a list that just keeps building. But anyways, right now our answers are 1 and 3, right? It's not 4, even though the subarrays that come from this part would have been 1, 1 and 3, and then 3. This is odd, this is odd, but then 1 plus 3 is 4, that's even. So we only keep the odd ones in this, like maybe like a building list or something. So when we move on to 5, now we say, okay, so 5 works on its own. So we'll take a 5, we'll look into our result, feel like that's very inefficient. Oh, and also, okay. And this wouldn't even work anyways. Because if I have everything in like this odd list, right? Like everything in here is odd so far. An odd plus an odd is an even. Odd plus odd is actually even. Even plus even. Okay, wait, so okay. Maybe I could draw some conclusions. So an odd plus an odd is equal to an even. An even plus an odd is equal to an odd. And then even plus even is always an even. So there's only one case that works. Oh, okay. So maybe instead of dynamic, yeah, but it's subarrays. So yeah, because I was thinking, oh, maybe we could just count how many even, and then count how many odd, and then we would get the number that way. But since it's subarrays, the order matters, or like they have to be like contiguous, right? Okay, but I think I could at least realize that an even plus an odd is an odd. I don't really like this example either. It's all odds. Maybe 2 for 6 is kind of hard too. Well, 2 for 6 has nothing. It's kind of annoying. I mean, maybe I do this example, but then it gets kind of drawn out. Whatever. I might as well do it because I have like 5% confidence in this right now. So I guess I just need to keep doing examples until I find something. 1, 2, 3, 4, 5, 6, 7. 1 is odd. 2 is even. Plus 2 is a 3. It's odd. Also, maybe this sounds weird, but maybe some sort of stack, like maybe some sort of maybe some sort of monotonic stack. Um, but I don't know. That might be a stretch. No, I mean monotonic stack is similar to DP, but honestly, it's probably DP. Whatever. Okay, so we're at 1. Actually, okay, if we were to do DP, let's get a little bit more serious about what are we holding? What does DP at like 0 mean? It's the number of subarrays with an odd sum. The number of subarrays with an odd sum if there were 0 elements. I think it's just 1, right? And then DP at 1 is if there was only 1 element. So it would be like right there. And what would that be? I think that's just one, right? Because this thing's right there. And then what is dp if the first two elements? So first two elements are this. We know that 2 is even. So, okay. Okay, okay. Okay. So we know that 2 is even. And remember, even plus odd. Was it? Yeah, even plus odd is always an odd. So even though we're at a 2 and we're like, oh, maybe we shouldn't use it. Well, we're not gonna count it as it's right, like the 2 as a subarray itself doesn't meet our criteria, but that doesn't mean we should just assign it a 0. We have to kind of look back because it's subarrays, right? And I think all we need to do is just look back 1. Yeah, because we always trust that the one before it had all the answers we're looking for. We don't have to like keep looking back super far, or else that would be super inefficient. And that's what I was originally doing. So I think what we can do is just look back 1 and see how many odd subarrays existed before. And in this case, there was only 1. So what does this mean? That means we know that at 2, there's going to be, there should be 2, right? The answer we're expecting is 2, and that should be a subarray of 1 by itself and a subarray of 1 comma 2, right? Okay. This is sounding pretty good. Wait, my hand's getting kind of tired. Let me draw this on the iPad instead. Okay, where am I in this board? Okay, I'm right here. Okay, just so that we know what we're dealing with here, I'm gonna do 1, 2, 3, 4, 5, 6, 7, and we are currently at 3, right? We're currently right here. So dp at 3. When there's 3 elements in the thing, what is our result? So our self is a 3, so we're definitely gonna add our self 1 plus, and then wait, this is interesting. Since we're an odd, oh, maybe, okay, wait, this is interesting. Maybe we need to keep track of how many even we've seen. Because at this point I'm at 3, right? Or like my value is 3, and how can I expand, like how can I, right now I'm dealing with an odd. How do I get to an answer of odd? The only way is like something's missing is I need to even, right? It can't be any other way. Like if this was a odd, that would just give me an even. That would kind of break everything I'm doing. So I'm actually expecting an even. So it depends on what index I'm on. So like if I'm on the value of the index, like if the value is 3, then I need to run like a DP of all of the even stuff I've seen in the past. Right? Because other than that, like it wouldn't work. Like I did one because I did a one right here because three is odd, but then I don't want to plus. Yeah, anyways, we'll see. Plus, let's just say what was in the past, and then DP at 2 is 2, so it would be 3. And does that make sense? At this point, what would it be? It would be 1. It would be 1, 1, 2, and then just 3 like this. Is there any other odd? Oh, there's. Yeah, I mean, so this is already wrong, right? Because um, 2 and 3. 2 and 3. 2 and 3 is there, but it's not accounted for in what I'm doing. Yeah, okay. And just to like double check, if I had my own test case and I had 1, 2, 3, what would I expect? Expect 1, 2, 3, 4, right? Yeah, we're expecting a 4. Okay. Okay. So I think this is going to be a little bit more tricky now, but I feel like I understand it. Um I feel like I understand it where I need to be keeping track of odd and even. So let me I guess we'll just have to restart all of this and just delete this stuff, delete this. Okay. So I'm going to have um maybe like DP odd and then a DP even. And it's the same as before, where we just return DP odd later, but we just need to keep track of DP even. Okay, so I think base case, let's just say DP odd at 0 is just 1. Same with DP even at 0 is just one option. Okay, so now let's actually start. We are currently on this, so that means DP odd when there's one element, it's going to be actually maybe it's 0. I'm not sure actually. It might just be 0. When the length is 0, how many odd subarrays? Well, there are zeros odd subarrays. How many even subarrays? There are 0. So okay, that makes sense. Well, okay, okay. So let's do odd. Odd at 1. And remember, odd plus even is odd. So if the current thing I'm looking at, which is 1, if 1 is odd, then I should do 1 plus the dp of the how many even there are at 0, right? And that's going to give us 1. And that correlates to this result right here, which kind of makes sense. Um, I'm trying to think. So now we have to kind of say how many evens were there with a length of 1. Well, since itself wasn't even, we just look back and just take how many evens there were in the past and keep bringing that over. I think so. So it would be like uh, just dp even. Yeah, just dp even of 1 minus 1 of 0, which is just 0. It's nothing. We don't have any evens subarrays so far. So that this is when I is equal to 1. Okay, so let's move on to the next one where we take shit. So the next one, now we're at 2. So dp odd with a length of 2 is equal to what? So we have to look at the actual value depending if it's odd and even. So 2 is an even. So since 2 is an even, we need an odd. We need an odd, so we can do how many odd there were. Wait, how many odd there were? No, how many even there were before? So dp even, how many even there were before? So even at 1. And if we're going to take all of those subarrays, wait, how many even? It's wait, how many even? Wait, so how many odd at 2? It's whatever. Since 2 is even. Wait, since 2 is even. Sorry. Since 2 is even, we need odds, right? So we need itself, which is that 2, into how many odds there were. dp odd like this, which is equal to just 2. And what is that 2? It would be one of them for sure. And then 1, 2 is the other one. Sure, I'll just do that for now. I don't know. I was spending a lot of time because I don't know if this needs to be some sort of like multiplication or not, but we'll see. I'll just try to convince myself that this works. So now, how many evens are there? Since it's even, we know that... Wait, how many even subarray? 1 plus dp even at 1, which is just 1. And that makes sense, right? Because what is that one subarray? It's just itself. It's just 2. Okay, let's move on. So now I'm at 3. I'm just gonna mark these. I don't know if you could see here. I'm gonna just say like 1. This is 0. This is 1. This is 2. And then let's go to 3 now. So what is dp odd when there are the first 3 elements? Dp even when there are 3 elements. So 3. So 3 is odd. So since it's odd, we need even, right? So it's going to be 1 plus dp even at 1 before it. So that's a 2. So that's 1 plus 1, which is equal to 2. And that's not correct. Or is it correct? I kind of see what I'm doing. I'm like, anyways, I'll keep doing this, but I'm only accounting for the subarray right now. So maybe I need to come back later and just sum it all up. Right? Because what is this tune? But then there'll be some double counting, right? Yeah, no, and also this is wrong. Like, right? If we want, oh wait, if 2 is even, if 2 is even, then just take the number of odd. We don't have to add a 1 to it. So it'd just be this. And then instead of 1, it would just be 1 and 2, because that's at there. The number of subarrays that, oh, maybe the number of subarrays that end at this index. I might need to write that real quick. So dp I, where I is the number of odd subarrays that end at index I minus 1 or something like this, right? The number of odd subarrays that end at index I minus 1. Okay, okay, hopefully there's a pattern. We'll see. So now I'm at this one. 3 is odd. So I want itself plus the even of 2. The even of 2 was just 1. So the even of 2 is just 1. So it's just 2. What would that be? That would be I believe that's just 2, 3, as well as 3 itself. Okay, and then how many evens that end at 3? It's going to be, well, since it's odd, we just want, oh, since it's odd, we definitely want dp of the odds of the one before. And what can we do with that? We can, oh, well, since it's odd, we can add ourselves to that. So that's going to be 1 plus 1 plus 1. So that's going to be 2. And then no. Wait. Maybe I'm doing this a little bit wrong again. DP, like how many even are at 3? We just need to take how many odd that ended. How many even? No. Well, since it's odd, we need to take how many odd that ended at the one before it, right? So dp odd at the one before it, which is 2. And then we'll just add our own to it. So that's how many even. That's going to give us 1, and that would give us 1, 2, 3. Because that would be a 6, right? Sorry, I'm really slow at this, but I feel like I have something going. So let me do a 4 now. We'll do the dp odd at length 4, dp even at 4. Okay, so what is 4? 4 is 4 is going to be a 4, which is even. So since it's even, we just add all the odds before it. So it's going to be just dp odd at 3, right? So what is dp odd at 3 is 2. So what two things end with 4? Okay, I see a 2, 3, and a 4. So I see a 2, 3, 4, as well as a 3, 4. Is there anything else? Is 1, 2, 3, 4 is not, right? Because that's 10. And then 4 itself. Yeah, so that's good. And I don't see any repeats so far. So I think that's good so far. And then we have dp at even. Well, since 4 is even, that means we... Oh, since 4 is even, and we could include 4 as well, it's going to be 1 plus, right? Because whenever we do 1 plus, whenever we do 1 plus, we're including itself as a subarray. Okay, that makes sense. So we're doing 1 plus how many evens there were in the past. 1 plus dp even at 3. So how many evens were at 3? There was only 1. So now there's going to be 2. And what are these 2 that end at 4? It's going to be 4 as well as 1, 2, 3, 4, right? So 4 as well as 1, 2, 3, 4. Okay. So now that we go on next, the next one would be a 5. I'm just going to say that right now. So dp odd at 5 is going to give us something. dp even at 5 is going to give us something else. Okay, so since it's an odd, how many odds that are going to end there? Well, 5 itself is going to end there, but then plus how many evens before? So it's just dp even, oh sorry, dp even at 4. And dp even at 4 was a 2, right? So 2 plus 1 is 3. And then what would that mean? That would be 4, 5, 4, 5, right? 1, 2, 3, 4, 5, because that would be 15. And then 5 itself, right? Yeah, okay. Sorry, this is getting messy. But then, okay, so how many evens are there when there's length 5 that end at 5? We know 5 is odd, and then odd plus odd is even. So just how many odd were there before? dp odd of 4, which is just 2. And does that make sense? If I were to just think about that, yeah, because odd plus odd is even, right? So 2, 3, 4, 5, 9, 10, 11, 12, 13, 14 is even, as well as 3, 4, 5, which is 12, which is also even. Okay, cool. I'm almost done. I feel like I already get the pattern. And this is going to be a long video, but I'm just going to keep going because this is good. So 6. dp odd 6, dp even 6. Okay, so 6 is what? 6 is a 6. So since it's even, we want even plus the odds. So it's just whatever was odd before. dp odd at 5. And that's going to be 3. And that makes sense, right? Because we'll have a 4, 5, 6. We'll have 4, 5, 6, which is odd. And then we'll have 1, 2, 3, 4, 5, 6. Wait, so 1, 2, 3, 4, 5 is 10, 15, plus 6 is 21. So we're just going to have 1 through 6. I'm going to do it like this. And then we're going to have 5, 6, which just gives us 11. So that's the 3 that end there. Okay, that's cool. And then for the even, since 6 is even itself, we just do even plus. So even we need to include, because we're just going to include the subarray of 6 itself, plus how many of the evens were there at the last step, right? So even 5 is equal to 2, so that's 3, and that's just going to be 2, 3, 4, 5, 6, as well as 3, 4, 5, 6, and let me just check that. So 3, 4, That's 10 and that's 18. Yeah, so that's even. And then one more, right? We just have this 6 right here, just the 6. So that's, and then we have this 6 by itself. So that's 3. That makes sense. Okay, and then we're at the very last one. Then I could actually start coding this. dp odd. Okay, dp odd at 7, dp even at 7. So, okay, so 7 is odd. So we'll include it. That's 1 plus even. dp even of the last thing. Even of 6. Which equals 1 plus 3. So that's 4 things. And that's going to be 4, 5, 6, 2, 3, 4, 5, 6, 7, 6, 7, 3, 4, 5, 6, 7. So all those. So I'm not going to write them all out, but it's everything that was in the even. So it's all of this right here, but then add a 7 in the back plus the subarray of just 7 itself. Okay, that makes sense. And then how many evens end at 7? So we know that since 7 is odd, odd plus odd is even. So we're just going to say dp odd at 6, which is 3. Okay, so now that we're done, they just want to sum up all of the odd ones, right? Okay, maybe so we want to sum up 4, we want to sum up a 3, we want to sum up a 3 right here, we want to sum up the 2, sum up this 2, sum up this 1, sum up this 1, and then sum up this 0, which doesn't really matter. But let me do that really quick. So how am I do this? So 4 plus 3 is 7, plus 3 is 10, 11, 12, 13, 14, 15, 16. And, oh, that's what they're expecting. Okay. Okay. So we got there. Took me 43 minutes to not even code anything. But hopefully this works. Okay, let me see. So I think let's just write out what we're doing. We need like 2 DP dynamic DP arrays or something. But it's like a map DP dictionaries. One for odd subarrays and then one for odd subarrays and then even subarrays as well. And I guess there's something that we need to notice, that odd plus odd is even. Odd plus even is odd. Even plus even is even. And since we're only counting the odd, like this really matters, right? This one really matters. And then what, okay, so dp at I, where I is the number of odd or even, depending on which dp array we're on, subarrays that end at that index. -1, okay. I think that sounds good. N is just the length of the array. Let's set up our DP. Okay, let's set up our DP odd. and then dp even. These are going to be, I guess these are just dictionaries, right? And then do we have a base case? I think the base case, we just start out like this. And then after I do all of this, I just need to sum up everything in the dp odd dot values, and then I think it's the sum of all of these modded by this number, right? The sum of all of the odd values. That's the key and value. Yeah. So then for I in range, for I in range n, we are going to do this one, which we're really going to be changing the I plus one. Okay, we'll see when we get there, but how does this work? So for I in range n, so the current number is the array at I. This is what we're dealing with right now. If num if the number mod 2 is equal to 0, this is what happens if it's even, else it's odd, right? So num is even. So what happens when num is even and we want to update the odds? Okay, wait, sorry. If num is even and we want the odds, we just need to take how many odds there were previously. dp odd I, which is 0. Yeah, we just do that. And then, so dp odd at I plus 1 is equal to dp odd at I. Or we go from 1 to n plus 1, and this becomes I, and this becomes I minus 1, right? And I think that's usually how dp works. Make it look better. And frankly, this needs to be I minus 1. So then we just fill this out, and what happens when the num is even? So that means our dp even at I is going to be 1 plus dp even at I minus 1. Right? So what happens when num is odd? Well, when num is odd, so dp odd I is itself plus all of the evens before, so dp even I minus 1. And then to update the evens, well, since num is odd plus the odds before it, so it would be dp odd at I minus 1. I think this is actually pretty solid. No matter what, we have to update our dp, right? And then that's it. Oh shit. Okay, that worked, but also I'm only doing this mod thing afterwards. I might have to do it for each one. This mod this needs to be this mod this mod this. Let me run that again. Okay, here we go. Oh, awesome. I'm I'm happy that I was able to get it, but why is it so inefficient? Um, Wait, everything should be very fast, right? If because I'm running the sums. I'm when you sum something, it goes n again. Um, so I guess I could just have the running result is just yeah, I mean I could just do res plus equal to dp odd dp odd at I. Is it like that? So that I don't actually have to do this, but I do need the modded right here. This mod dot just return res. This might be faster. Wait, what? Wait, I'm confused why this wouldn't work. Because after I filled out all of these, I just need to add it to res and then I return the res. Maybe I'm modding weird. Oh, I see. Actually, everything I'm doing is fine. I just need to do this as well. Yeah, that's gonna be fine. Oh, it's still really bad, huh? Because all of this is just linear. It's linear, right? Maybe okay, maybe I'll do this one more time where I take away all of this. But I think this is bad practice, right? Because it might get super large. Doing what are we doing here? We just do so let's run that. And then I think this is, if the other one wasn't efficient, I don't think this would be efficient either. Yeah. Anyways, well, that could only mean that maybe I don't even need DP, and maybe the answer can just be done using like some sort of math thing. But let's see. I'm happy I got it down though, because I had like zero confidence. I remember like early on into this video, I was like, I only know 5% of it. But then after like drawing out these cases, it helped me realize a pattern, and then also come across like a couple key things about odd and even, right? Like two odd numbers create an even when you sum them up, or like two even numbers are even. The only way to get an odd sum is when you add an odd number plus an even number. Let's look at the hints. Can we use a cumulative sum to keep track of all the odd sum subarrays? Yeah, I don't know. Does this mean DP? Yeah, it does mean DP. Oh. Well, traverse the array in reverse? Sum all the odd subarrays? Oh, maybe, okay, so maybe what's everyone's doing to make it faster? Because I think my solution is like this. Yeah, I'm doing the dynamic programming approach. But then I guess there's a faster way to do it using prefix sums. And what is this Quizlet? Oh, so this doesn't even, yeah, okay, so here's the like counting or the math thing that I was talking about where they don't even use anything to store, right? Like it's the memory is fast. And then I guess since you don't have to look up stuff into memory, it's just all instantaneous, then it's much faster. But it takes prefix. Yeah, it's an O of 1. If the current prefix is even, add the number of odd subarrays. Wait, wait, wait. Wait. My answer right here is actually not so far away from the thing, right? Because we're always looking just at the previous. So can't I just turn it into um like odd, even, right? Um if num is 2, odd at I is equal to odd at I minus 1. So odd C doesn't change if it's even. Odd count doesn't change. Even does though. Even C is 1 plus even C. Odd is odd count is 1 plus even C. Yeah, 1 plus even C. And then if the number's odd, how many are even? What's the even count? Is the DP of odd. So it's just the odd C. Wait, what? Number is odd. So So that makes sense. But then I probably want to do the even count first. The even count, which is just the odd count, because we're just gonna add it to ourselves. So it's gonna be like this. Then the result is just the odd C. And then you can just do that. Let me run that. That's interesting. This is even. Oh, what? Even C. Well, this is gonna kind of ruin it. Unless I did something like this, right? Even C, odd C is equal to odd C 1 plus even C, something like this. Let's run that. Okay, that works. Let's go ahead and submit. Nice. Okay. Yeah, and this makes sense. Like whenever we do those dynamic programming problems, like those like really basic ones, like climbing stairs, like how many stairs that it takes, or like how many like different ways to get to the top, all of those is using dynamic programming. But then at the end of the day, it's the type of dynamic programming where we only look like back one spot, right? So whenever we look at one spot back, that's almost just looking at previous. So we could just kind of turn dynamic programming into just like a just like two variables that hold, like this could have been previous, right? But then when you do something like that, you just need to make sure that when you update your variables, you update them in the correct manner. Like I want to see if this would have worked if I did 1 plus even C, right? But I already updated even C, so I don't think this would work. What am I trying to do? Right, let me just run this. It's not gonna work. Yeah, it's not gonna work because you're updating even C where you really wanted to use the old even C's value, which actually, now that I think of it, you could just do temp even C. Then you can do this, and then you could do 1 plus temp if you're really desperate, right? Yeah, or you could just write it on one line like I did before. I mean, what did the editorial do? Oh, they actually, I didn't do it in a prefix sums way. Never mind, ignore that. I did it in just I did it in dynamic programming, but just take out the whole like dynamic programming part of it and just turn it into variables. So it's much faster and it saves space. So this is O of 1 space, and then it's also linear, right? Because it just runs from 1 to n. Yeah, so honestly, this problem felt good. I started out not knowing, I had like zero confidence, then 5% confidence. Then after drawing out the pattern, it was like 75% confidence. And then after it submitted, like 90% confidence. But then I was kind of bummed out because I only was beating like 5%, right? Something was wrong. So I just kind of like modified my answer a little bit to include just quick lookups so that we don't have to like drain a lot of space complexity, which improves the time complexity for like looking up stuff. And then now I'm satisfied. So yeah, hope you guys enjoyed this video, and thanks for watching.